Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's Ichikara puzzle. I think it was rated easy for a group of three, so this should be probably fairly easy. Um, Here are the rules, and it's question mark by Michael Lefkowitz. I guess it's 9 question marks to match the 9 question marks we have in the puzzle. Anyways, we have Ichikara, where we need to divide the grid into regions. A region contains the numbers from 1 to 9 once each, where n is the largest number in the region. And the regions may also contain empty cells, and question mark stands for any number. So a valid region could be something just like 1 by itself. That is a valid region because that is the numbers from 1 to 1 once each, right? But if you have, say you have a region with 5, you would have to have 1 through 4 also in that region. So 5 cannot just be a region by itself, it has to contain the digits 1 through 4 also. So you could have something like this as a region, and this would be valid. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, 5 obviously cannot be in the same regions as each other, so we'll mark these as region boundaries. Therefore, this 5 has to go here. It's 1, and then this can't be in the same region, so this must be a separate region too. So this will mark as green. This 1 has to go out somewhere, so it goes 4, and it cannot be in the same region as the 5, so these are separate regions. That means this 5 has to go out this way. We're going to mark that as yellow, or mark this as pink. Red has to continue out. Yellow has to continue out. Yellow cannot go through this 3. Can't go through the 1, so it has to go this way. The red region cannot go through the 1 because we already have a 1 in the region. So these are all separate regions here. The 3 has to go out this way because there's no other place for the red to go. So the green has to go this way, which means the pink has to go this way and then that way. Green has to go this way because there's no other place for it. So these are all boundaries. This is a boundary. Red has to go this way. Yellow has to go this way. Okay. So yellow needs access to a 4. How many digits do we have? We have, this is 5, 9, 10, 11. And this is 20. So all of these have to be in a region from 1 through 5 because we have 4 5s. That means each region with a 5 must contain a digit for all the digits from 1 through 5 once each. Since we only have 20 digits in total, all the question marks must match with the digits 1 through 4. Because we have 5 5s already, or 4 5s already, that accounts for 4 of the digits. That means we have 7 digits here. So this 1 must be either green or pink. We're not sure which. Okay. So this has to go out here. And it's green or pink. So the yellow must continue this way. The green or pink, whichever one. So we're going to mark this then as blue. We don't know which one it matches to. It's either the green or the pink. But it must be separate from the yellow. So the yellow has to go this way, which means this is a boundary here. The blue has to go this way, which forces the red to go that way, forces the green to go that way, forces the pink to go that way. The pink has to continue here, which forces the green to go that way, which forces the red to go this way, which forces the blue to go this way. Therefore, yellow has to go that way. Yellow has to continue to get a 4, so that forces blue here, which forces red here, and this is a 2. So that's a 2, and this is done as a region. Yellow has to continue this way, so yellow goes here, then here, and that's a 4, and that's done as a region. The blue continues on to here. We have green going here, pink going this way, green has to go this way, and green needs to continue, so then green is the same as blue. So this is all one region, which forces pink to be here. So then this goes this way. That's done as a region. And we don't know what these are. It doesn't matter. It's 1, 2, or 3 in some order. So this is 2, 3, 4. This is 1, 2, 3, 4 here. And that's done. So I guess we should just go to the next one because this is all considered easy, and this is done as an Ichikara. I don't know how to solve it because this is 2, 3, and 4 in some order. There's no restraint here though, so we don't know which specific digits are where. There doesn't have to be actually a specific digit anywhere. We just know this is a 4, that's a 2, and then this is 2 through 4, and this is 1 through 4 here. Okay, so that's done there. On to the next puzzle. We have flower. Okay, actually, I'm going to open it in a new window so that we have them all available. Okay, same rules. Divide the grid into regions. A region contains the numbers from 1 to n once each, where n is the largest number in the region, and they may contain empty cells. Question mark stands for any number, and this is called flower. So, how many digits do we have? We have 4 1s, 4 2s, 4 3s, 3 4s, 3 5s, 2 6s, 1 7, and 1 8, and a question mark. Okay. So we're guaranteed at least 1 8. The 8 has to be with a 7. 4 1s, 4 2s, and 4 3s. So every 2 must belong to a set of, must also be in a region with a 3. And the reason why we know that is because the question mark could either be a 1 or a 2, but it cannot be both. If it was a 2, we would have 5 2s and 4 1s, which means every 2 would not have a 1 in its region, which is not allowed. So this could be 1. So what can it be? It could be 1 here. It cannot be 2. It cannot be 3 because we have 4 3s. It could be 4 because we have 3 4s. It cannot be 5 because we have 3 5s and 3 4s. And again, we have the same problem. If this is 5, that would mean we only have 3 4s to go with that. It could be 6 because we have 2 6s. It could be 7, 8, or 9. It cannot be 10 because that's larger than, it would not have a 9 to be in the region with it. So the 2, each 2 is guaranteed to be in a region with a 3. So it cannot be by itself. So the 2 and the 8 have to be in the same region guaranteed. The 1 does not, though. The 4, this 4 needs to be in a region, so it must be in the blue region. So the blue region cannot go here. The blue region needs access to a 7. Okay. This 2 is a region. This 2 needs access to a 3. So that's X. There's that. This 2 needs access to a 3. And it could just be these. Can it ever be here? No, because then the 3 would be blocked off from having a region. So these must be in the same region. And it could be with 1, it could be with 6. The 1 could be by itself. So the 2 and so the blue region can never be with this 7. So then this 7 has to be with the red. So this has to be a 7 here. And it must access it. So this is blue. Okay. If we block that off, so the blue has to exit out. It cannot block the 3 off without the 3 being part of its region. So this is 3. This has to be blue. It blocks off the 5, so this is part of blue also. That means red cannot access this. Blue can't be here. Blue can't enter the 5, can't enter the 4 or 2, and the 3, so it must enter the 6. So blue has to go this way. And this is, we don't have, so we have 1. Orange needs access to a 1, so that's 1, which means that's a border. This is a 7, which means this is 1 through 7 here, so this blue matches that. This must match the red then, so this must be a yellow. Red needs access to 3. It has to go this way because it's blocked by there. And then 2 is blocked here. We need access to 4 and 6. If it goes 6 here and 4 here, this 1 is blocked off. So this 4 is not valid. It has to go to these 2. So these 2 are the final parts of red. Obviously doesn't have access to yellow. Has to go out this way to connect. Yellow has to go out this way to connect, and then this way, and then it connects that way, and then blue goes all the way around here. And this is the regions for this block, this puzzle. We have 1, 2, 3 for orange, 1, 2, 3, 4, 5, 6, 7, 8 for blue, 1, 2, 3, 4, 5 for yellow, and 1, 2, 3, 4, 5, 6, 7 for red. And that's how you solve the flower puzzle. Let's get on to division Ichikara. This has the same rules, so let's continue. Whoa, that's a lot of numbers. Okay, we have 1, 9, 1, 8, and 1, 7. So those are all the same region. So we're going to mark those as blue. We have multiple 6s, 3 6s, 5 5s, a lot of 4s. 1, 2, 3, 4, 5, 6, 7, 8 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2s. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 1s. Okay, so we have 1 each of 9, 8, and 7. So we have 1 9 set. We have 1 9 set. We have 2 6 sets. So it's not going to be easy to write this. 1 9, 2 6s. How many 5s? We have 5 5s, so that means we have 3 6s. Oh, yeah, we have 3 6s before. So that means there are 2 extra 5s also. There's 2 5s. Jeez. So we have a 9. We have 2 6s. We have 2 5s. So that's 5 5s accounted for. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 3 4s sets. That We have 8 fours again, right? 1, 2, 3, 4, 5, 6, 7, 8. How many 3s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 3 3s. So we have 3 3s. So we have 1 9, 2 6s, 2 5s, 3 4s, 3 3s. I think we have 1 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have 11 3s. So we have 1 2. So 1 9 set, 2 6s, 2 5s, 3 4s, 3 3s regions, 1 2. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I think we have 14 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 1 2 and 2 1s. Okay. It's not easy to make a set from this, okay. So the 8 is surrounded by a 1 and a 2. The 7 is surrounded by a 1 and a 2. So it must enter, they must connect to the 9 from just 1 and 2. Guaranteed. That means the 9 cannot connect to 1 or 2, so we know this is a boundary here. And it must connect through a 3. This 6 is surrounded by 1, 2s, and 3, so it cannot access that. This 6 is surrounded by 1, 2, and 3, cannot access that. Okay, so let's remove all the digits that we added in, even though it's going to be hard to remember, because this is just confusing me. So this blue cannot access this one, cannot access this 6, it must access this 6, and it must access it through a 4. So this is a boundary. Actually, it doesn't have to go that way. It could access the 5, though. Cannot access the 5. If it has to exit out, it can only exit out through 5, 1, 3, 1, 3, 1, 1, and 5. So it must exit out through the 5 to connect. So this is all blue. Technically, this doesn't have to be it could be part of blue, but we don't know. We know this is all blocked off. This has to go to blue here. It needs to access a 3. Can it ever access? Okay, so we have 6, 5, 4, 3. We have all the numbers already for the blue. It must access. It cannot have any sharing with any other digit. So how does it access the 9? It has to go through this 3. So this is done now. And then it needs to access the 7, so it has to go that way, because it cannot connect to any other digit. And to connect to the 8, it can't connect through 2, so it must connect through 1. So it has to go that way. And this is all done. So this is one region here. Though, okay, so technically it could go through any of the blank ones. It probably doesn't. So 1, 2, 3, 4 is a separate region here, because this 4 needs access to 1, 2, 3, so it accesses all those. We have 3, 4 regions. Okay, so this 2 and 1, this 2 needs access to a 1, but it could be just done there. We don't know. This 6 needs access to a 5. The only 5 it has access to is here. Let's make this yellow. So this will be orange and orange. It can access the 5 through 1s or 2? No, it has to access it through a 1. Right? So how does it access? Okay, how does it access this 5? It would have to access through 1, or it cannot go through double 2. So it has to go through 1, so this must access that way. It must access through 1. It has to be one of these two ones. This is a separate region, so this cannot go anything there. Could be 1, 2, 3. This could be one that way. It could be one that way. Hmm. This 4 must access a 2. And it has to access the 1 somewhere here. Because it cannot go this way, because then it's blocked here and it's blocked everywhere else. So it must access the 1 through here, so this is not part of that region. And if we try to access 2, I think this has to be part of orange. Yeah. This must be part of orange, because there's no other way. This 4 cannot access any other 2. If it tries to access here, it can't access this because that's through 2 ones. So if it tries to access here, the 5 is blocked off. So it can't be. So then this is part of orange. Connects that way, connects this way, and then we have a 3 that's somewhere. This is a separate region. We'll mark it as yellow. The orange, this 3 needs access to it things, so this has to be an orange. So that's 3 with 1, 2, 3, 4, 5, 6. This is a separate region. This 3 needs access to... This cannot be 3 here. This is all done here. So this 3 needs access to a 1 and 2, so it has to be that way, which means this is a boundary there. This 4 needs access to 3, 2, and 1, so it has to be these. So we'll mark that as yellow. This will mark as pink, and that's separate regions. We have 3 5s here. Okay. This 2 needs access to a 1, so this must be part of the same region. This 1 could just be by itself. Actually, no, it cannot. We have already accounted for all the singleton ones because we know there's 2 of them and they're both here. So this must be part of a separate region. 1 5. Let's see. The 6. The 6 needs to be part of either this 5, or this 5. We're not sure which. It could just be part of this 5. That seems to work fine. Can it be part of this 5? It cannot enter this way. Can't go here because it needs access to the 2 if that's the case. Can it go 3, 4, and then that's just blocked by 3 and 4? So no, pink cannot be part of this 6. Can yellow be part of this 6? Maybe... No. It cannot be part of this 6 either. Because if it tries, how does it connect? It can't connect through the 2 or the 3. So this is blocked by 2 and 3. Because it can't go through 1. And this is going to be 2 or 3. But if it tries going this way, it has to necessarily go through 3 here, and then 2, and that's multiple digits. So this 6 must be part of this 5. Okay, let's make that green. So these are connected. Cannot just go this way and then enter there. Can it? Okay, so if it tries to connect to this 4, the problem is this 4 doesn't have a region. So this must be part of the green region. We need access to a 3. Well, if we try to go 1 here, the problem is if we go 3 here, that's blocked from the 6. So it cannot go here, it has to go connect through here. If we try to block here, the 4 doesn't have a region, so that's not valid. So it cannot go here. Therefore, this is a boundary. This is a boundary here. So it must go this way. So it connects there. This 2 cannot go to 4 because then this is blocked then. So the 2 must be part of the green region. This is interesting. So this could be any of them. We don't know. Huh. This is 4, 3, 2. Wait, that's problematic. So that cannot be right. Huh. Um. Okay. So then we show that that doesn't work. If we tried having this 4, 2, 3 is blocked by 2, 3, and 4 and doesn't have access to a 1. So this cannot go this way then. So then it must be with this pink set, right? Otherwise it just doesn't work. Well, shoot. Uh. No, we have a problem. Hmm. How does this work? Hmm. Is the blue? I think no, the blue's right. So to access the 7, it's going to be 1 or 2. To access the 8, it's 1 or 2, which means the 9 cannot access through the 1 or 2. It must access through the 3. That means 1 and 3 are 1, 2, and 3 are not accessible for the 6. So it cannot access this, cannot access this. It must access this through the 4. And to go through, we don't have access to 1 or 2, 1, 2, or 3. So it's blocked here, it's blocked here. It wasn't necessarily blocked here, but it's blocked here and here. So where else can it go? It must go through the 5. Yeah. So this could be 1, 2, 3, 4, 5, and this could be 1, 2, 3, 4. So let's try that, I guess. How does this work then? The problem is this must access through a 2. So the problem is this 2 here. But the blue needs... I don't understand how this is going to work. Hmm. This access through 1 or 2, but maybe this... No, but this access to 2 through 3 also. Oh. Ah, that's the way. So it has to go that way. Right, so this is, again, 2 and 5. This is 1, 2, 3 by itself. Yeah. So this is the pink needs access to 4. So that's 4. This 3 doesn't have access to 1 otherwise. Or 2, so this must go that way. And then this is a region by itself. Oh, that was tricky. Huh. And this is the last region. 1, 2, 3. So this orange is 1, 2, 3, 4, 5. We have 1, 2, 3, 4 here. Obviously, the blue has 1, 2, 3, 4, 5, 6, 7, 8, and 9. This orange has access to 1 through 6. 1, 1, 2, 1, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, and 1, 2, 3, 4, 5, 6. That one was a little tricky. That was a bad, how do you say it? A bad assumption here. I don't know why, yeah, I thought it had to go through both, but it didn't. It just had to go through the 2. Hmm. Well, okay, so that be a lesson to you that, be careful about the assumptions you make. Though it did force me to try this path and then find out that that couldn't work, obviously. So, that was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.